This example deals with the process optimization in a wastewater treatment plant. The day-to-day management of the plant includes the control of the input of wastewater, the sludge and the clear water produced, as well as the careful selection of chemicals. Our goal is thus to use historical data to create a model or duplicate the process with a double objective: predict the age of the sludge or the time the solid remains in the tank and the oxygen chemicals needed for biological treatment. Let's look now at the flowsheet, which again could be as simple as a 2D BPMN file or a 3D sophisticated BIM model. In both cases, the sensor or active sensors are displayed, colored as per the rules set for the nature of the data or the KPIs. As to the BIM, we could navigate through the 3D model, as can be seen here, and identify the location of the sensors one by one, allocate, enable, or disable them. Once that is done, we move to the IoT here to connect the sensors to the platform, to create rules. Once that done, we simply go and create our projects. We now turn back to the Project tab and pick up the one for predicting chemicals for the biotreatment phase. The dashboard, depending on which tank we're looking at, would exhibit important variables such that the flow rate coming into that tank, the oxygen demand, ammonium rate. Looking now to the biological treatment, the dashboard presents other variables, again, chemical oxygen demands, total nitrogen, total phosphorus. Data Analytics tab will allow creating a pipeline for machine learning model to predict the variables in question. A digital twin again is to interrogate that model. And if we go straight to the Insight Hub, we see that it shows more KPIs than before. For the primary treatment phase, for the biological treatment phase, some general constraint, and finally, and more importantly, the optimization simulation for future use. Primary treatment here, we could see the efficiency of oxygen demand chemicals, the same for NH4 increase, with some average values obtained through basic statistics. If we go to the biological treatment, we'll see again the DOC efficiency again over time, the total phosphorus efficiency over time, and the same for NOx. The same average KPIs shown on the right. The General Constraint tab shows thresholds for the different quantities, thresholds that the system cannot allow, as we see here for every variable. Otherwise, an email is sent as an alert to the user that the constraint might be violated. Let's see finally what happens in the important tab of optimization. Here we could see the energy consumption optimized, summed up for the aeration system, the pump system, the mixing system, anything mechanical requiring energy. The same year, we could see the constraint, the values or the rate of violation of each of the constraints for DOC, for NH4, for phosphorus, etc. And we see whether it is in an acceptable range, for example, here below 10% or not. That closes this chapter of wastewater treatment plant.